So the title is like deliberately kind of catchy to attract attention. It seemed to have done the job. It was called Data-Centric AI, which is not a term that I invented. It's been around for a few years. And then I recently then at the last minute added the explainable bit because that's really the part that we, as part of our research, are trying to add to this equation. Okay. I should add that I'm part of one of the AI projects called AI Multiply, but I will not be talking about AI Multiply today. Ask me offline if you have any questions for that. Okay, so this idea of data-centric AI has been a kind of a buzzword for a few years, and I have a couple of slides to try to convey the main concept, assuming that you may be not familiar with this. So that on the left side is Andrew Ngo, who is an authority in AI from Stanford, telling us that basically you can achieve remarkable improvements in model performance with a model being an AI model, essentially by improving on the data rather than continuously obsessing on the performance of the model itself and the architecture, hyperparameters, and so forth. And that's kind of the point of this idea. Just cleaning the data has a cost, but that cost really has a large return on the investment. So that's a case for good old data cleaning. And then if you move forward, this idea has been picked up by a number of groups. This is one close to us, in fact, from the Van der Schaar group in Cambridge, who's also very close to Turing. And this is, I picked this slide because it illustrates very well the main concept. This is basically the now phases, data training, deployment, but these phases have all loops going back, which implies that you're never essentially done when you do ML ops and you deploy and you start monitoring, then you will be forced to go around the loop for various reasons. So no, this talk is not about going into a deep dive of the details of each of these boxes here. If you are a data engineer, you probably recognize things on the left. If you are a AI modeling expert, you probably find things that are familiar to you in the middle, and so forth. Okay. The point is that this new idea that the data plus model equation really has been biased towards the AI side and modeling side a bit too much, and now it's time to take a second look at the data. Now, this idea is actually taking off in the mainstream. And just to reinforce the idea, I'll present a couple more slides on this. So what are we talking about? The main concept is the model training data intervention are becoming entangled. This is what's happening with data-centric AI. And the point that I would like to make is that, well, we know we are learning how to do model-based explanation quite well, but database explanations are not as well understood. And in this new ecosystem, which is really an end-to-end, it makes perfect sense to actually try to merge them together, okay? And the question is, what is the best way to do that? It is kind of an open question. We believe we have one possible path forward, and I'll try to talk about data provenance as one of the possible ways that you can go about doing that. I'll talk about, I'll use healthcare, which is my domain. As I said, I'm affiliated with Multiply, I'm a co-I there, to try and explain the concept of contextual explanations for this. Okay, so I promised a couple of more slides on this data-centric AI and ML. And this is just to say that there's a flurry of new papers, mostly trying to survey the concept. As you can see down here, this is pretty recent, end of 23. So these are really coming up now. I think it's a timely topic to be interested in, and I think it is important to engage with this if you are in the AI space, the traditional modeling space. These are all quite similar. Then I put another three kind of semi-authoritative papers here. They all kind of insist on this idea there are multiple iterations, so really the job is never done, and you have to react by promoting data interventions in reaction to things that happen to the model, for example, data drift, concept drift, and so forth. This bit on the right is like the escalation, the super linear explosion of number of publications that talk about data-centric AI. So is it just a buzzword effective? Okay, well, let's jump right into one example. And I have longer talks where I picked on multiple examples. We only have time for one. I choose this because it comes from an organization called, or a working group rather, called DataPerf, which is the data equivalent of MLPerf, which is basically a working group designed to produce benchmarks for machine learning tasks. And about part of ML Commons, and I like the ethos of it, okay? So DataPerf works by promoting challenges. For example, I'll give an example of a challenge in a second. The overall goal is challenges are taken up by groups around the world, and the goal is to demonstrate how you can actually improve model performance by improving the underlying data that eventually makes into training sets. Okay, so here's an example that I picked. It's a challenge about correcting mislabeling, which is a common occurrence. And as we know, or probably most of you know, in supervised learning, annotations are expensive, and incorrect annotations are expensive to spot and correct. Okay, so the setting here, there's an open image benchmark data set. It's perfect. And so you baseline the challenge by saying, look, I give you a training set. I start from a perfect training set, a subset or open image. All images are labeled. There's a classification task, and I measure the performance that can achieve on that task. Oh, okay, that's my baseline top performance. Okay, and then the scenario is realistically, let's imagine that some of these labels are not correct, are noise. So the training set is noise. And your challenge is to identify the minimal set of labels that need to be flipped or corrected in order to achieve a performance that approximates the perfect, the P, which is the perfect performance, okay, baseline, all right? And so then groups go off and do their job here. And this is organized in two sides. There's an evaluator side and a competitor side. So on the evaluator side, you basically, from DTR, the evaluators corrupt some of the labels and they throw it over the fence to the competitors and says, this is a noisy data set. You do whatever you want. What you need to return is a ranked list of labels that you want us to flip. And then we're going to test the training on that training set that you give us one at a time. So we flip one, test, measure performance, flip another, and so on and so on, okay? You can come up with any strategy that you want. So basically, you as a competitor go around this loop until you're happy and say, okay, this is now my list. The score is given in terms of how many labels I need to flip down your ranked list that you gave me, right? I'm an evaluator, before I reach a threshold, which is, X% of the optimal performance. And the winner is the one that actually has the shorter list that needs to flip, because you managed to pick the most important labels to flip, which is the whole point of clever data annotation. So I think this is a great example of data-driven, model-driven data interventions, where the model performance drives the interventions to the data, and you don't have to be perfect. You just basically need to be good enough and efficient enough to satisfy the requirements of the model. Okay. All right. So that's the example. So now let's go to explanations. Come back to the example in a moment, okay? So what we used to look at in the AI space, and the Turing is a champion of this, is what now we call Model X, which is model-based explanations. For example, from the model outputs, you can actually identify the most relevant training examples that influence that particular output, okay? So what I'm suggesting is there's a whole data processing phase here that has been neglected for a long time. And I called explanation at this level data X, okay? And they go from the training data set to the source data set. And that's basically where data-centric AI is inventing. So the community is coming up with these clever algorithms like the one I just illustrated And wouldn't it be nice to be able to capture the essence of these algorithms and make those explainable? Because that plays into the trustworthiness of the entire end-to-end pipeline. Okay, they may be sophisticated black boxes, but to the extent that I can explain at some level what they do, I'm in business. Okay, I can promote that. So these are the data explanation questions that emerge from this kind of framework that I try to set up. You know, at the data set level, how was the data set processed step by step? So this can be multiple things happening in this data processing. And then go down to the individual item level and says, which data items have you touched? And why have you actually touched that particular data item? So that's what I mean by data X explanations. Okay. So in a running example, this translates into, okay, I want to document the fact that the version DI over the training set was derived from the original noisy one that was given using CS, which is my cleaning strategy, as part of a longer pipeline. I want to know which data labels were cleaned and why they were cleaned. And these are increasingly complex questions to ask, okay? Which data set was derived from what is actually fairly simple to capture. We're talking about automatically capturing this information, okay, making it efficient. Which individual items were cleaned is also fairly easy, and I'll show you how to do it. Why they were cleaned is a lot more difficult, and I think that's where the exciting work is laying ahead. Okay. So there's the promise is that if I can provide this explanation, then I can hope to reuse some of these black boxes safely. And safely means I kind of get an idea of what happens at each end, okay? Although I might not be able to look inside, okay? So, and the vision here is now to be able to acquire all these clever algorithms. I only give an example, but there are many others. In this data toolkit, okay, make it curated in a way that it is basically reusable and explainable in a safe way, okay? The way that we suggest to achieve that, or one path forward, is to try to automatically enable the observation and capture of what happens inside the black box or across the pipeline. And the challenges to do that is, okay, how much can I actually observe, and the granularity at which you observe. So you can be very granular, but that doesn't actually translate into useful explanation, or very generic and it doesn't convince anybody, okay? And really plays into who are you explaining to, which I'll come to at the end. So there are two dimensions, really. One is what you're explaining, and the second is who are you explaining to. I'll try to join them together towards the end. Okay, so I said, sorry, there's a ProfDB here that probably people have missed. And that's basically the key technology that I would like to talk about. So provenance is essentially a way to record what has happened to data through a variety, a sequence of transformations. It's a model using a data model that we call Prov. I was involved in promoting that and standardizing it about 10 years ago. Fundamentally, you have the concept of entities of data, which is produced or consumed by activities, i.e. processors. They can also be filtered out. So invalidation is I throw away a piece of data, and then derivation is mediated by these processors. So I can change the derivations. There's more to the model, but we don't have to get into the details. One thing that is interesting is that Prov is deliberately left high level and abstract, and you can extend to domain vocabularies in a principled way, which is useful in this case. Okay, so let's jump into an example here. So now my cleaning strategy here, I start easy. It says, look, I have input and output data sets, okay? And my cleaning strategy is an atomic unit of processing, black box, but I can still use that to address reproducibility questions. For example, well, I observed the eye, where does it come from? And I said, well, it was generated by this particular version of CS, my cleaning strategy, which used the noisy data set. Okay, and by the way, I can unfold this. I can tell the story of multiple versions of my strategy, which incrementally produce a better and better version of the noisy data set. I can also do attribution. I can say this associated with, meaning that someone is responsible for that, or someone I can email or call on the phone if things go wrong. Okay, yeah, as I said, I can unfold this into iterations. There are lots of technicalities here that are not really important for the main message. What I think I'd rather tell you about is this idea of provenance actually happens in layers. So there's an outer layer at the dataset level, and then if you go one level down, you can either break up the process itself, but let's assume it's still an atomic processing, or break up the data. So it's no longer just a data set, it's actually a set of elements. And now you can be more granular. You can, for example, say that one particular element xij was derived from one particular element xnj, okay? So depending on the nature of the processors, I can sometimes keep the granularity and says, this particular item was derived from this particular item here. And that is actually a much more interesting piece of information because I can answer questions as, where does this number 32 come from? Oh, yeah, because it's a result of an imputation step. And before the imputation, this was null. And why was it null? Where did it come from? Or it came straight from the source, or maybe from some other, in some other way, okay? So that potential you can capture a lot, depending on how observable the whole system is. And this brings us to the point of observability. The approach that we've been following to try and demonstrate there's some value in this idea is to install an observer at the interpreted level, at the very practical, in a very practical sense. We take Python scripts that operate on pandas data frames. And if you're not a programmer or data scientist, don't panic. It's basically a data abstraction, which is just a table, and Python is the way to write your script. It turns out that you can instrument Python interpreters to observe what goes on behind the scenes without really disturbing the programmer. So it's mostly transparent to the programmer. Okay. So we have a little history of trying and do that. The latest is actually this very conference here. So Luca has been the main implementation engineer here. And actually, I presented this just yesterday at this conference. Okay. So this is still going on, of course, and there's lots to do. Data provenance for data science, the main concept is the following, right? So you have an abstract operator here, D, that transforms D into D prime, and then D prime, it's a training set that we use to do training and so forth, okay? So if op is actually a Python script, we can almost certainly do something for you, which depending on how you write your code, you can write as an operator, which is basically encapsulated into a Python function, or you can actually write just code blocks, okay? Either way, we are able to generate these little fragments of provenance that I introduced earlier. And at the data level, at the data set level, that's actually fairly easy to do. But because we can actually look at each data frame that is produced and consumed at each step along the way, we can actually go inside and be more granular and trying to accomplish this fine granularity promise that I mentioned. Okay, so here's a pipeline. An example is very simple. It's just a join and then a dumb imputation, another join, another imputation. Then this is a slightly more complex sequence, which is a one hot encoding operation. Okay, that produces D6. So I would write a Python code that looks pretty much like this. There's nothing strange about this if you're familiar. If not, just believe me. And then what happens is that with minimal code instrumentation, I can actually provenance enable this code. So I can create a tracker, which is an object of class provenance tracker, which we created, of course, and then say the tracker subscribe to the data frames that are interested in monitoring, and then essentially everything else follows transparently. I can actually encapsulate this little code block for the one-hot encoding by bracketing. It says suspend provenance, resume provenance to say this is kind of a bracketing. These are just details, okay? Right, so with this, let me give you an example. These are actually, mini data frames that are operated on by this, the first part of this pipeline. And I can, the provenance actually it now becomes a graph. We store it in a Neo4j database. And we can then ask questions like, okay, this A sub I row 1 is a value which is now dummy called imputed. Where does it come from? I said, well, okay, provenance tells me that it comes straight from this non-value, which is in the same position in the previous version. But this non-value actually is the C1 value here in the right arm. And so that means that if you pay close attention, this is an outer join. That means that all of the FA was retained and some of the FB. And basically that means that, well, C1 didn't actually have a matching value on the left side. So basically there's a bunch of nulls that were created as a result of the join. Okay, maybe you didn't notice that, but now you know, and then the imputation has occurred. Okay, so that's a kind of reasoning at the very granular level that this enables you to do. Right, it doesn't actually do silly things like replicating the provenance of data that hasn't changed. So it only records the changes, right? If A4 has never changed, then there's no point. Well, this particular link is actually not explicit. Okay, these are implementation details. Right, so let me zoom out. This is like a provenance basics in 5 minutes. And the idea now is that if I convinced you that there's something here on the DataX side, and there's a lot of emerging literature on clever explainability methods for the AI side, would it be nice now to put them together? Okay, so that's, if my animation works at this point, the idea is that, so let's take one example from a paper. This is a very recent, well, it's actually 22 paper. This is a ICML paper. What they do is they propose a explainability feature called AME, average marginal facts, which is a generalization of Shapley values. For those of you, again, that might be familiar, that's a reference point. But essentially, the idea is that now explainability means that given an input, so given a prediction, okay, so the ground truth for this example, these are images, of course, is cats. And the model gets it wrong because it predicts airplane, okay? And the interesting thing is that now can query the model that says, why did you think there are airplanes? Okay. And then the AME algorithm will retrieve elements from the training data set, which actually are the ones that were used based on some statistical properties, okay? So statistically likely to have been used, I should say, to come to that conclusion. And they say, well, these all look like airplanes, and therefore I decided this was an airplane. Actually, this was a cat, and you got it wrong. But now it gives an idea to the basically the implementer, the AI expert, how to move forward. And the idea is that we want them to attach provenance to it, okay? So now if you give me these examples, I say, well, where do these images come from? They seem to be maybe blurry images. They shouldn't be in a training set. Maybe they've been poisoned. There've been an adversarial attack and I haven't noticed, and now I spotted this, okay? So the provenance bit adds depth, essentially, to this Model X explanation. So I think the two things really have a potential to go well together. And then I said earlier on, there are two dimensions: what you explain and to whom you explain. And the to whom is super important because there are multiple stakeholders in this AI game. There are basically what I call AI clients, okay? In the healthcare example that I promised I would come to, in our practice, we see essentially two categories of stakeholders. So what I recognize as two broad categories. One is called AI clients. They all have a vested interest in making sure the AI works well, and they will work with you in a co-design setting, co-development settings. In Multiply, we have a fantastic PPI group that works with us on a regular basis, We have clinical PIs and QIs that work with us on a weekly basis. It's very much in sync with the AI expertise, okay? There are also other nurses, administrators, other roles, there's lots of roles, okay? However, I would claim that they're not really primarily involved in the development and validation of AI. So the kind of explanations that I just illustrated, that probably wouldn't be for them. They would be for the data and AI specialists. And these would be data controllers, data scientists, and AI experts. Data controllers, again, in this setting, would be the people are the organizations that are responsible for example, all the NHS data that is currently being integrated into these famous ICS, integrating care systems, which will be implemented in the form of the SDE in the UK, for those of you that are in the country, secure data environments, okay? There's a big integration effort. At that point, these data controllers really have a vested interest in being aware of where the data goes from the system onwards into AIs, okay? So you really want to have a way, which we call the provenance, to walk backwards from the models back to the SDEs, okay? And this also plays in with the responsible AI ethos, where these two categories really should work together, and in Multiply that is working very well. And each stakeholder will have a different role. If we achieve this, I think it's going to be a healthy AI and data ecosystem. I think the healthcare professionals and the AI clients have the legitimate requests for explanations, but those to me are quite hard to quantify. For example, they will want, the doctor will want to expect to have a quantified confidence in the model output, which is now called epistemic humility. So how confident is the model in its own predictions, and so forth, okay? Ultimately, I believe that the clients will hold the specialist accountable for the trustworthiness of the product, and therefore the specialist is the one that should be targeted first. It's also easier to formalize the problem, to be honest, as computers and data scientists. So let me then go towards the conclusion with a quadrant slide that try to capture this idea of what you're explaining at the top and to whom you're explaining. And I think we're doing a good job up here in the top left corner, where there's lots of technology being designed by super clever AI specialists. Influence functions, the AME that I mentioned is in this category. What I think is missing is basically data at end-to-end explanations that cater to data controllers and the specialists. And that's the focus of our current research. And then in a broader sense, you eventually want to provide contextualized end-to-end explanation that really cater to the other stakeholders that may not be interested even in the destiny of one single data item at a time, for example, at the granular level. And to put it in perspective, this now is the picture that I have for what I consider, our current research agenda. So there's an end-to-end pipeline here. I omitted the loops. There are loops. And then if I convince you that we have some ability to observe and record what happens here, and there's also lots of model explanation technology that's coming out, then would it be nice to then use both and combine them to build an engine that provides contextualized explanations to each stakeholder group and caters to each of them separately. Okay. And so with that, I would say that, okay, I added here that this really is a social technical kind of co-design exercise, and DPDS could be used as a starting point. That's my pitch. Okay, this is really my last slide at this point, where I try to put things together. Okay, my attempt to make sense of this thing that I called XDCAI, or Explainable Data-Centric AI, in the middle, where you basically have a combination of model training, model explanation, data intervention, and data explanation coming together and interleaved in complex ways, and everything then caters to stakeholders. Without that to whom bit, nothing really makes sense. We just write in another paper with all respect, it's fine, but we're not going to have a lot of impact. Okay, And with that, I think we are pretty much on time. I apologize if there's actually background noise, but I would actually be happy to stop here and take your questions if there are any questions. Thank you very much for sticking around.
Thank you, Paolo. So in the meantime, please feel free to use chat to ask questions. And if you feel comfortable, please turn on your camera and you can ask questions directly as well.
I have not been able to obviously follow the chat. I'm not that multitasking wizard, so please help.
That's okay. Batu has been keeping a close eye.
Okay, all right.
So first question is this session recorded? It is recorded, but we promised not to record the Q&A. So we will actually stop the recording